So hello everyone to this second video on process design. In the previous video, we spent a lot of time talking about the different process types. So we've seen this diagram. This is a very important diagram on the job shop, batch, repetitive, and continuous types, and we've seen the difference between them. Now, we didn't talk about layout. Now, layout is basically going to be very important, and we said one of the most important implication of process design is the layout. Toyota manufacturing plant is going to look completely different than a hair salon. So the implication of what the process type we choose is going to have huge implication on the layout. So now, usually we could say that on the right, the repetitive and continuous are going to have a product layout. So it's going to be product layout. While on the left, it's going to be process layout. So a product layout is basically our layout has to do with the product. So for example, for manufacturing the car, the whole assembly line is going to be based on what is going to be assembled on the car. So the assembly line is going to work from the first is going to be sequenced in a way so the first things that are going to go on the body of the car are going to happen first, and then each other part is going to happen in sequence. So the layout really has to do a lot with the product itself. In process layout, it is actually the process that becomes quite important. The process becomes quite important, and everything is, the layout is basically influenced by the process. So for example, in a bakery, the ovens are going to be in one place, then there's maybe another place where once things come out of the oven, they're packaged or so on. So the packaging, so each process is going to be in a different location. One very good example of this is probably in a hospital. In a hospital, you'll see that, for example, X-rays are going to be grouped in one place, then the blood tests are going to be grouped in another. So it is basically the process, not the product, and the product in this case we could think of as the patient that walks into the hospital. While in a car manufacturing, the car that walks through the assembly line, everything in the layout is influenced by that car, while in the hospital, everything is going to be influenced by the processes that the customer is going to go through or visit. So now, of course, there is advantage and disadvantages to each one of these layouts. Now, the process layout is going to be less vulnerable to shutdown. So so basically, if the X-rays got shut down, there's a shutdown in the X-rays, a patient could still do a lot of other examinations like blood tests and so on. While in a product layout, once a shutdown happens anywhere in the assembly line, it's going to stop the whole assembly line. So another one disadvantage of process layout is setup cost. So for example, a patient walking into X-ray, the patient has to wait. The X-ray room has to be probably reorganized, or maybe the machines need to be turned on again or reset and so on after each patient. So we end up with so many different setups, and if a patient is going through three different processes, then There's 3 different setups, so that affects it, that makes it inefficient, while in a product layout, there's only one setup, and that setup is gonna work for the whole large volume of production output, so large volume of production output. So now let's look at the product layout, and one advantage of it is you're gonna have a high labor machine utilization. People working on assembly line, their job is quite repetitive, and by experience, they're gonna get much faster at doing the same job. And the same thing with machine utilization. You're using big machines, so your utilization of the machines is going to be higher, and the layout is going to take advantage of this. There is little work in process or work in progress. Now, we haven't talked a lot about work in progress or work in process, but think about a garage shop where you go to fix your car. Probably you're going to see a lot of cars that are waiting to be fixed, or cars that are halfway done but they're still waiting for a part to arrive. You're going to see all sort of things on the floor. It's probably going to look much messier than a car manufacturing plant. You're going to see a lot of things that are waiting to be completed, what we call work in process. And this is a disadvantage of the process layout. In a product layout, you're going to have very few of these because things are happening really quick in a fast way, and especially when we go into things like concrete plants and plants that are oil refineries, then there's not that much work in process. Now, one disadvantage of product layout is the general purpose tools. Product layouts, they use big machines and very specialized tools, so they cannot take advantage of general purpose tools. Now, general purpose tools, think of them as like screwdrivers and hammers and things that you could use on more than one product. These are general purpose tools. So think about these general purpose tools are things that are going to work on more than one product. And again, since they are general purpose tools, they could be driven to lower costs, because you could produce a lot of volume of these equipment and sell them in high volume, so you could take advantage that they're going to come at lower costs. While for product layouts, these tools are going to be much more the specialized tools are going to be more expensive. So the last type of layout we're going to be looking at is cellular layout. So which is basically like is in the middle between product layout and process layout. It takes advantage of the two, puts them together. And the idea here is we want to group we're going to group machines, and this is coming especially from product layout. And we said product layout is going to have a lot of disadvantages in terms of flexibility, so they're not flexible. So the cellular layout is going to provide more flexibility, and it's going to turn it into semi-process layout, because you're going to be grouping machines. So group machines, so we're going to group machines. So we're going to group machines. The pen is not writing anymore. So now the pen works. So we have the cellular layout, which basically is going to group machines that process product with similar processing requirements. So instead of just having a layout that is based on the product itself, we could be creative about finding certain processes that are in common between products. So for example, maybe all our products, more than one product, use the same cutting procedure. So the cutting is the same. then we could group them in machines. So we could group the machines that do the cutting. So cutting machines, we group them in a cell, and that's gonna allow us to have more flexibility. So we're producing more than one product at a time, while not, so the setup cost is not gonna go really high. It's gonna keep, so we keep it in a moderate level, and we're able to aim for multiple products. So the idea of cellular manufacturing, the main advantage is we're going to reduce setup times. We're going to be increasing the number of products we could make. And we're going to basically take some advantages of product layout and process layout at the same time. Now, very important to us is going to be the grouping of labor. So when we have layouts, we're going to group our layout in our labor in terms of work stations. So if any of you have summer jobs, you've probably seen this already, that people are, especially even in service, you see this, that people are grouped in stations or in offices or in office space, common office space. And the reason for this is this grouping is gonna basically stabilize the capacity and basically maximize the output. That's the idea. So what's very important for us when we talk about workstations is to balance the workstations. So for example, let's say you're working for a credit card company that is basically issuing credit cards. So maybe there's a process of verification. So there's some verification activities that need to happen. Then maybe there is some approval activities that need to happen. And then there is the issuing of the credit card. So let's say you have 3 workstations. So workstation 1, so that's called workstation 1, workstation 2, workstation 3, and each one of the workstations is doing its own activities. But what's very important for you is to make sure that you balance these workstations. So there's no one workstation that is overloaded with work while other workstations are not so overloaded with work. So to have basically so basically the workstations have approximately the same time requirements. So they take, so workstation 1 takes, let's say, 10 hours to do to process 100 claims, and then the approval will take 10 hours, and here 10 hours, or approximately 10 hours. Then you would say that you have a good line balancing. So the idea, what we call this is, we call this line balancing. So in order for us to go ahead and do line balancing, we have to understand what cycle time means. So cycle time, so let's take workstation 1, which does verification. So verification of all the data and so on. Now, the time, or the maximum time allowed for workstation 1 to complete all the verification tasks, all tasks that have to be done for verification on one claim. So it is basically an estimate for each claim. So how long does it take for all these tasks to be completed for one claim. This is what we call cycle time. And cycle time is going to be basically the operating time per day divided by the desired output per day. So how much is your desired output? How many applications you want to do per day? If you want to do 10, then that D is 10. Now the operating time is basically the working hours of people in that workstation per day, taking out breaks and other things that don't add, that they're not doing work in. So basically maybe if they're only working 7 hours out of the 8 hours, so it would be 7/10 in this case, and we get 0.7. So 0.7 hours per each unit. So that's basically what the cycle time is. So let's do some examples on cycle time. Another equation to look at before we move on to do the questions is the equation that helps us estimate the number of workstations. So sometimes we don't know the number of workstations. We want to decide on the number of workstations, and that would be the sum of tasks for all. So for the previous example where we done verification, approval, and issuing, we're gonna look at all the tasks in these workstations, add them up, and that's our sum of T. Of course, we don't know the workstations yet because we're trying to estimate the workstations, and that's over the cycle time. And also, if we look at this, then we could calculate the cycle time if we know the sum of tasks over the number of workstation. Or by the way, this is the minimum number of workstations, not the maximum number of workstations. So let's do a question. So I'll give you a few seconds to read the question. So in this question, we have a meat processing plant. We have 3 consecutive tasks. They're telling us they've decided on 4 workstations. So we already know the N minimum here, which is equal to 4. They've decided on that already. So we know the number of working stations. Task 1 takes 4 minutes, task 2 takes 5 minutes, and task 3 takes 3 minutes. What should be the optimal cycle time? So cycle time is basically, we take this equation right here and we just solve for the cycle time, CT, which happens to be the sum of T divided by our number of workstations. So we end up with 4 for our first, plus 5 plus 3 divided by N, which happens, they told us what N is for workstations. So we are gonna end up with 3. So the cycle time for this case is 3. Since we're using all the task times in minutes, so our cycle time is going to be 3 in minutes. So we'll stop right here with this video, and then in the next video we're going to do more examples on cycle time, and we'll do the line balancing.